Cool. Yeah, we're live. Awesome. Awesome. Welcome everyone to Crack Code Interview Problems in Python, episode 2. This is a series where we're working on code interview problems in Python, obviously, but this is an interactive series. So we want your comments. We want you engaged in the chat. We're going to ask you questions. We want you to ask us questions. And so because of that, we must insist you follow our code of conduct. This has been pinned to the chat. So please don't be a jerk, be kind, or we'll ban you from all Microsoft events. And with that, let's kick off this stream. I'm super excited today. I'm joined by Dr. Sarah Kaiser. So Sarah, do you want to introduce yourself?
Yeah, hey everybody. My name is Sarah. I am a senior cloud developer advocate at Microsoft for kind of scientific Python-y things. Basically, I started shooting lasers at satellites a long time ago using Python and Jupyter notebooks. And so I got a PhD in quantum computing as an experimental physicist and have been kind of doing a variety of like research, engineering, R&D things all the way to kind of now somehow software development, which as baby physicist Sarah, I would have never imagined that would be something I would want to do full time. But it is super fun, and I love hanging out with folks on stream.
Awesome, awesome. Thank you. Well, I'm really excited to have you here. Last week we had Jay Miller, who's a colleague of yours, and they had one approach to doing things. And I'm really excited to see what your approach things will be. So those who don't know me, I'm Jim Bennett, cloud advocate at Microsoft. It's my job to do things like this stream. So I get to hang out with cool folks like Sarah on stream, do cool code stuff. Now, as mentioned, this is a live stream. We want you to get engaged in the chat, ask your questions. Yeah, you can help us try and solve these problems. Yeah, we're going to ask you things.
Yes,
we want
please.
your feedback, all that kind of stuff. So please, please, please dive in the chat. If you're on Twitch, you may see a few comments about a Learn Go on Azure series that was running on Twitch before this event. That's now moved to a different platform. So if you're expecting to learn Go, not Python, then you need to check out the switch over to the Tech Days. Check that in the Twitch chat. So yeah, before we kick off, question for those folks in the audience: who was here last week? So if anyone watching at the moment, who was here last week, and also where in the world are you? Last time we had a lot of folks from all around the world. So I'm interested this time to hear where you are. So please jump in the chat and let us know. Now, Sarah, I do have to, and I know we should be focusing on the problem, and I know we got heavily derailed last time, didn't get very far, but I do have to ask, using Python to fire lasers, isn't that like the coolest job ever?
It was really fun when they told me that that's what I could use high-powered lasers to start plasma fires, and I could use lasers to try and send, basically it was trying to send single photons to satellites in space. I was like, you know, the Mission Impossible gif, I'm in. But yeah, that's what I did for my PhD. I worked on quantum key distribution devices, or kind of more generally like quantum cryptography hardware, which is like using the same technology that like quantum computing and or very small physical systems, hence the quantum physics part, to do much simpler tasks than full computing. In this case, basically just share a random bit string between two places. So even 10 years ago, there was commercial devices you could buy to do this. And basically, I was developing hardware to do this to space, to send the keys, and then also basically doing pen testing on existing commercial devices to basically see if I could sneak in and blow them up and get the key, notably. Obviously, you can always blow things up, but maybe... which is an end in itself, but perhaps not actually what you want to do.
Yeah. If you're trying to hack something, blowing up is probably the least effective way to do it.
Yeah.
Is that all the quantum entanglement thing where you have like two photons that are entangled, so you can send them to different places, and when you change one, it changes the other, so you kind of get that instantaneous communication thing. Is that?
There's no instantaneous communication, but yes. Nothing travels faster than the speed of light. That is the... but yeah, absolutely. That's why photons, like I love photons. I love light and lasers, as you can tell. But they're some of the kind of simplest to work with, and like quantum systems, because you just like turn on a flashlight, turn on a laser effectively, and you have them. So
just imagine the Python lab, pip install lasers. Lasers not on,
Well, like my first open source contribution was basically all of our lab equipment had a variety of operating systems they worked on. One was like Windows 95, then Windows XP, and keep in mind this is in the year like 2015. So basically what we ended up having to do was use Python and kind of serial communication packages in Python, even some that were specialized for controlling scientific experiment or scientific hardware, like instrument kit, that basically allowed us to make classes representing our different devices, the capabilities for those devices, and we could basically store what either weird USB strings we had to send, or some of them had the like big serial, almost even SCSI port sort of connections.
Wow.
And we just
big chunky multi-pin. Oh,
yep. But we had to reverse engineer a lot of them because they didn't come with documentation. So yeah, that was, you always think there's like super glamorous things that you end up doing for, even shooting lasers into space, but most of it was just trying to look at serial monitors and figure out what was getting sent when you push a button.
Yeah, because you do have that image of you're going to be like almost like a super villain. You get to control lasers. The first thing you get is a white cat to sit in your lap and stroke as you're coding. As you say, it's just I've got a big plug. I need to plug it in and work out the data going over it. So less white cats, less volcano bases. Jessica Walkenhurst. Walkenhorst is in the chat, says, "Hi, I'm in London too, and a fellow computational quantum physicist. I did my PhD using coding to optimize lasers to change photonic properties of molecules." Wow, serious stuff. That's really cool. Jessica, maybe we should get you on a stream with Sarah as well. It's just the two of you can geek out about lasers and quantum properties of molecules. That's cool.
That would be fun.
But yeah, there's a lot of folks in the chat. So Ghost is saying me, I guess me for being here last week, and I'm from London. And Deborah Thompson, also here last week, is from London as well. Yeah, we find, so we're both in the Pacific Northwest. So for us, it's 8:30 in the morning. And we find we get a lot of folks from Europe joining these streams because it's your evening. So you can finish your day and then come and hang out with us. So welcome. Joe Bell is in Massachusetts. Welcome. Noor Zulizam is watching from Malaysia. Unith in Colombo in Sri Lanka. KJ Miller. Jay is in the house. Awesome. Glad to have you here, Jay. I hope Sarah's not going to poo-poo too much of your ideas from last week. Unith is shocked at Jessica Walkenhorst's using lasers as well. Eccentric Supervisor's back. Greetings, devs. Glad to have you back with us. Awesome. Alistair Sanchez says, I used to do experimental particle physics. It's true that we had to maintain our own device drivers. Brings back good memories. I'm glad they're good memories. Sarah, would you say yours are good memories?
Yes, the coding parts were really actually the most fun to me, because I learned kind of my first programming language, which I'd love to know what people in chat's first programming language, and also yours, Jim. But mine was Mathematica, so it was like in notebooks. I had like the idea of writing in a like text file and running a script for some reason seemed scary to me, but a notebook was friendly. And so when I found, like, as I was trying to learn Python, I was like, oh, there's notebooks. Oh, this will be good. Like, I can do this. I can write, it supported LaTeX, so I could write all my equations and stuff and actually meaningfully document what I was trying to do. But yeah, I feel like a lot of time physicists and other applied, like my school didn't really have a lot of CS I had to take. And I basically in C2 learned computer science, realized I really liked it. And now I do it full time, because turns out computer scientists have thought about a lot of the problems that we were running into and might have come up with solutions, but you kind of just got to ask first. Like version control. I can't count how many times I've taught scientists Git.
Yeah, because you're using computers to solve a problem,
Yep.
that's related to your field, your scientific field. You're not using it as a computer scientist. You're not using it as a software engineer. It's like, I just need to use this application to solve my problem. And it's like people who use Word to write docs. There is version control kind of built into Word. It's just people don't know about it because it's not something you necessarily need to think about. Yeah, my first programming language was BASIC on the ZX Spectrum back when I was like 5-6 years old. And my mum used to help me type in listings because I was too little to actually have the attention span to type them all in. Yeah, the Spectrum came this big orange book with code in it, and you go and buy magazines and get books to the library. These are pre-internet days. This is like almost 40 years ago. And yeah, you have this long listing to type out for, like, this is how to do hangman or noughts and crosses, tic-tac-toe. And of course I would type for a while, and then my mum would take over and type for a while. She wasn't into computing at all. She just enjoyed using them, enjoyed playing games. She was actually a nurse by experience. So, but yeah, the two of us would just type for a while. The other one would take over and type, and then I'll take over and type. And but yeah, actually, like you, when I was doing computer science university, well, when I was looking towards university, computer science wasn't a career. Yeah, the careers master that we have, so, you can go and be an electrician. That was his big thing, wants everyone to be electricians. No mention of computer science. So I did a chemistry degree, and part of that, I actually did what's called computer-aided chemistry, where we did do some computing. And we would connect like titration pipettes up to a computer and write a little bit of code to kind of turn it on, turn it off, check the color, turn it on, turn it off, check the color. Again, didn't touch things like version control, but just enough code to do the thing we wanted to do. And that kind of got me hooked. Went on from there. I
have played around with those basic machines at the Computer History Museum.
It makes you feel old when, the hardware you grew up on is in the museum. So Jawad Alam is from London. Francesco Mertes is from London. Alistair Sanchez, who was doing the device drivers, is from Nice in France. Awesome. Oh, nice. And Jessica Walkenhorst reckons that Alistair Sanchez is the most hardcore folk for doing the device drivers. And Peyton Kellogg says, good morning from Seattle. And first language was Ruby. Biased to compare newly learned languages to my XP with Ruby's 00 forward plus high human readability. I've not done Ruby. Have you done Ruby, Sarah?
A couple of times. I think I had to poke at the internals of Jekyll, but that's about it.
Yeah, I know Ruby on Rails, I suppose, was the framework for web development for a while. I think it was Stack Overflow was built on it or something, or GitHub was built on it. One of the big ones.
GitHub still is.
GitHub still is. Okay. Today I learned. Ghost says my first language was BASIC as well, around 7 to 8 years old at the time. For some reason, I taught it to us in school. The reason being, I guess, it's fairly basic. It's. I guess Python is now the basic of the modern age, isn't it? You don't hear about BASIC anymore, but kids are learning Python in school. Like the Raspberry Pi Foundation is doing such great work to get computer science in front of kids using Python. And there's so many great Python books. I mean, up on my shelf up there, I've got like 4 or 5 Python books for kids. My daughter, my 10-year-old, has been dabbling a little bit in Python as well. So I guess Python is the new basic, isn't it, in some ways?
I think the way I kind of think about it is in almost any problem you're trying to solve, it's probably not the best choice, but it's going to be the second best choice for everything. So in terms of like my Swiss Army knife that I'm going to pull out for like if I just need to take a first stab at something, or just my kind of go-to default, Python is great. Because also, if I Google what I'm trying to do, most likely someone's made a package that I can just install and use for it.
It's that well-established ecosystem, isn't it? There's probably someone's solved that problem already.
I don't pretend my problems are novel.
Yeah, I've been dabbling a bit with Rust recently, and one of the problems I find there is the ecosystem isn't quite so good, so you don't quite have all the packages for everything yet, whereas with Python it is. Someone's already done it, Faiz Khan says Ghost here. Realized was watching from the wrong account. Okay, so Faiz Khan is Ghost. Okay. Alistair Sanchez, I first read about BASIC in our old library years before I had access to a computer. Then I had a semester in university study Turbo Pascal. Never had real life application. Ooh. I did a year's internship during my degree working for what was then SmithKline Beecham, is now part of GlaxoSmithKline, the big pharmaceutical conglomerate, using Delphi, which is Object Pascal.
Ah.
So it's like the Pascal version of Visual Basic. That was going back some. God. Cardamom, hi, I was here last week from Columbia. Brian Abbott is from Bellevue. First language was C and then C++. Yep, going at it hard. Nice. Oh, there was the villain of the internet a few days ago was talking was somebody whose daughter was like 10 years old, was trying to do games programming in C++.
Oh, I saw that.
Wanted to be a princess programmer, put on a princess dress and code in writing games in C++. It's like, if you're 9-10 years old and you're writing C++, you are amazing. You are exceptional. Doesn't matter how bad your C++ code is. That is just incredible as a first language to start with, especially at that kind of age. So, you know, we need more programming princesses aged 10 years old trying C++. Joe Bell's first language was Fortran. Jessica Walkenor said, did anybody else use Delphi at school as their first programming language?
That came up right after you had said what you did about Delphi.
Yeah, anyone else used it? I'm intrigued. It seemed really big at the time because you kind of got the performance of C++ almost-ish with the flexibility of Visual Basic. It's a good language. Brian Abbott says NumPy has array broadcasting, hence massive pi pickup and machine learning. So I can say A times B, where A and B are matrices or tensors, and it will do the column row multiplication. Yeah, I mean, it's huge for machine learning. Absolutely huge because of the libraries, because of the ecosystem. I mean, Sarah, your background is a lot of kind of data things at the moment in machine learning, data science. We actually had someone asking last week about data pipelines. And we said, oh, come back next week because Sarah might be the person to ask about that. So would you say you're a NumPy expert?
I won't ever say I'm an expert at anything. That's too much commitment. But no, I use NumPy a lot because the reason I went into quantum physics over other physics like fields was, you know, you had to do like these weird triple integrals for like electrical engineering. And then they told me that quantum physics is all modeled by matrices. And I was like, oh, I know how to make computers do that math for me. So, yeah, like basically learning my homework buddy was NumPy and SymPy and stuff like that. Because that was most of what we were doing for the actual quantum mechanics part. It's just manipulating giant matrices, which is basically why the quantum computing field more generally has pretty much adopted Python as their preferred user front end.
So going back to your point about someone's probably written a library for it, someone's written that library in Python that happens to do what you need. Nice. So Jawed Adams said, that was me, the data pipeline question. Okay, so Jawed, this is your time. We have the expert online. So yeah, what's your questions on data pipelines? Sarah can hopefully help with that. Alistair Sanchez, Delphi looked so nice back then. Sorry for paraphrasing. For making nice UIs. Yes, get some lovely UIs. Just an observation to the folks. We are streaming on YouTube and Twitch at the moment. So if you're on Twitch and you're wondering where that question came from, that question came from YouTube. Same as if you're on YouTube and we're getting questions you're not seeing, they're on Twitch as well. That's why I put them across the bottom of the screen. But if you're wondering why we're replying to people who you don't see online, that is why. Cool. Okay, so Jawed, yeah, drop your data pipeline question in the chat. So let's actually think about some Python briefly. I'm just gonna get my screen up. So last week we started working through a problem, a Sudoku solver. Didn't get very far because we were chatting with everyone, and I'm imagining it'll probably be the same thing today, which is cool. Happy with that. We started putting the code up on GitHub. I'll just make sure I drop this link in the chat for everyone to, if you want to come and find the code and follow along. We've also, if you are interested in Python and you're not an expert, I mean, I am far from being an expert, but if you want to up your Python skills, we're running what we call a Cloud Skills Challenge, which is like a gamified learning experience. So we have this challenge here. We've currently got 30 people signed up. Fernando Leandro has completed 12 out of 12 modules. Other folks are there learning Python. And it's a whole lot of 12 Python modules, covers everything from getting started with Python in Visual Studio Code, Boolean logic, lists, while and for loops, managing data, getting started with Jupyter Notebooks. There's a lot of good stuff there that you can learn. Just get a link to that dropped in the chat. So if you want to learn more Python, Cloud Skills Challenge is a good place to start and compete against everyone else and see if you can learn as much as Fernando Leandro. Aldo Garcia says, I'm in Miami, Florida, and my first was C++ and Java. Nice. Nice. Welcome. Welcome. Yeah, Java's kind of been an interesting one for a lot of folks to learn. It was the de facto OO language for a lot of universities recently. A lot of them still teach it, and it's amazing how many people still use Java. You kind of don't hear about it. It's not cool. It's not the new hotness that some languages are, but it's everywhere. It's so many enterprises use it. I mean, we find at Microsoft it's one of the biggest backend languages people use. So Eccentric Supervisor says, does quantum computing involve working on real systems or approaching over problems using formal models of computation and then working them over real systems? Pardon me, I don't know much about quantum computing. Totally fair enough. So, Sarah.
Both. So what's been really exciting to me kind of recently, I actually gave a talk at GitHub Universe last fall with their launch of Code Spaces. But basically, there's a full development stack for quantum computing now that's, you have your front end in Python, or there's some other domain-specific languages like Q#. It has nothing to do with C#. Sometimes naming is bad. Oh, thanks for finding it. But yeah, basically...
Sorry about the noise there.
There is real hardware that you can use and connect to. Pretty much all cloud providers have some. There's Azure Quantum. IBM and AWS also have. But what's exciting to me is you're not really bound on that because we're developing like compiler tool chains. So like if you're a fan of like LLVM or kind of all the tools that would take normally to take a, user kind of level abstraction language down to really FPGAs are the last stop on the kind of like computational pipeline to go from the algorithm you're trying to write all the way down to sending microwave pulses or pulsing lasers or whatever. There's a lot of fun stuff in between. And actually Rust is now becoming one of the most popular. We basically go from Python to Rust. Rust works with LLVM and MLIRs and stuff like that. And then you compile that to, whatever your kind of custom FPGA architecture is. But yeah, I may have written the book on that called Learn Quantum Computing with Python and Q#. But yeah, it's really, really cool that you can do all of this. Before it's been pretty hypothetical, or like you basically had to be a researcher to get access to do anything fun. And you can just download Python now or Q# or whatever and get going.
So I just dropped a link in the chat to some online learning around how to create your first Q# program to do a random number generator. I'm just going to drop a link in to Sarah's book as well. So if you are interested in that book, highly recommend you hit up your local independent bookstore and order a copy. Huge fan of indie bookstores. There's an indie one here in Redmond where I live, which I absolutely love to bits, and
brick and
always
mortar?
buy stuff from there. It's brick and mortar books, yes.
I love brick and mortar.
Yeah, every week after my daughter's drum lesson, we go in there and we buy way too many books. So it's an awesome one. So yeah, if you're interested in Sarah's book, find your local indie bookstore and get a hold of it. Cool. Yeah, I keep going to quantum computing talks, trying to understand it, and I haven't quite got there yet. So one day I should probably pick up a copy of this book myself, actually, and try learn it.
I mean, I really view it as learning, like if you're learning a new microcontroller or something like that, where, the operations on the chip, there's some, I mean, maybe you have access to direct like add sort of instructions, but it's just like a new device, you have a new book of instructions that it can do, what, that are described in this case by matrices. So you know exactly what happens with when you use that operation, and it's just finding the right ways to combine those. So there really isn't anything magical, mystical, insert whatever trope you want, and no, there's nothing in two places at the same time. Please don't ask. But yeah, Rust is, you'd mentioned before doing some of these with Rust, and I should probably go through your videos on doing that, because mostly the Rust Python integration is really great. Just for the record, out of the box, it is pretty easy.
That's what I've not actually tried already. Because in Rust, you can compile it down to libraries that got the same interface as like a C library, can't you? So you can, the same way you can wrap C code in Python. In theory, yeah, you can wrap Rust code in Python.
It's a Rust crate called PyO3 that like literally will directly pass to Python, like Pythonic errors. Like you can do error handling back and forth with very, very little code. Like it's very smart. So like I knew what I was doing in Python and basically just had to plumb up a couple pipes. I was just trying to basically pass a text blob that was reading an LLVM file between the two. Because the Python LLVM support, I couldn't find the right package for, and it just didn't exactly make sense. So, but yeah, highly recommend if you're trying to work with both and you want like the speed and benefits of Rust while using Python as your front end, PyO3 is great.
Okay, that's cool. That's cool. I'm curious now. Is there an element called PY? Because no, there isn't. Is there? Because I'm just thinking back to my chemistry days, because PyO3 looks like it's 3 oxygens on a PY atom, which would mean it could be a rusty whatever it is. You think rust is iron oxides. This is like pi oxide almost. I don't remember an element called PY. So but go on if that is the play on it, whether it is like it's a rusty pi.
That was my interpretation. Yes.
Cool. Sneaky jokes. I love them. Okay. Faiz Khan says, I forked your repository and wrote my own solution for the Sudoku problem. Awesome. If you want to share that, you could drop that in the chat and then we'll just steal it. I mean, we'll check ours against yours later. But no, if you're interested in sharing that, it'd be cool for other people to see how you solve the problem. Hopefully we'll get around to maybe looking at the code in a minute. Ragathian says, my first was QBasic. Nice. Kind of one of the good early basics. I remember that Microsoft QBasic with gorillas.bas was the one. You make the game with the gorillas where you threw bananas at each other. That was cool. Okay, I guess this is the data pipeline question from Jawad. What are some emerging trends or technologies in the field of data pipelines that you find interesting or exciting?
Well, see above. I think some of the interop between Rust and, I mean, Python is, as noted before, a really great Swiss Army knife if you just need to do some data transformation. Like I don't touch Excel. I just import it and use pandas for pretty much everything. Something that I have seen that is really kind of cool is kind of the emergence of WASM, or the Web Assembly Standard. Do you know what WASM stands for, Jim?
I thought just Web Assembly, because ASM is the short for assembly.
Okay. Then that's it. I just always hear WASM. But basically the idea that you can, for portability, take whatever tool you're using, compile it to WASM, which the idea is then any browser, there's basically an API that you can implement, that browsers implement, that effectively creates sandboxed runtimes. So this is actually being even used on embedded devices where basically all they do for their FPGA or whatever is they implement basically a runtime that can run anything in WASM. And what that means is you kind of have the ultimate portability at that point. You can run things in your browser, you can run things on any platform, but it allows you to get compiled stuff places. And, you know, kind of in our case here, that is used as a part of PyScript. So there's, I think it was about a year ago, it was a kind of a project announced where basically you can run Python directly in your browser. And why I think this is kind of cool is it can make exposing. There's lots of obviously great ways to collect data. Like, you know, we have local scripts, you know, things like Azure Functions and stuff where you can just easily ping and add things to databases. But something that I think is always kind of a little bit challenging is how to share those results. And so having, I mean, the things that I really like and I'm seeing being done with like PyScript are like dashboards, but where you can do actual executions. You're not relying on something pre-computed, or you're not relying on having some backend you have to connect to. So you can just do it right there in the browser. So kind of the broader way I could summarize that is seeing new ways that we can make those pipelines portable, which allows us to kind of reach different, because like say, for example, you don't have a great computer. You want to actually visualize some of the stuff with your data. You could use your browser and you don't have to worry about anything locally on your machine. Or you could use code spaces. I mentioned that before. That's basically free runtime compute on GitHub. But yeah,
I guess you can scale it up as well, can't you? Because if you can run anywhere, if you need to put it, you can just, if you need to put it on a more powerful machine, you rent a virtual machine in the cloud, spin up a browser on that, and run the code on there.
Basically, yeah. But it just means like a lot of the issues you were talking about before, like Rust compiles, so it exposes a nice, you know, sort of C-like interface. But you could take very different languages, like Rust compiles to WASM. I could take Python that compiles to WASM, or I don't know, pick another language, C# that compiles to WASM, and like all of those could be run together. You know, obviously you need to expose API bits, but you know, it just kind of makes that end collaboration between, because the thing in data science is you never get the luxury of a kind of monolithic pipeline or infrastructure. You're always, at least in my experience, feels like you always have either legacy bits that you need to include, or you're working with multiple different people with different, just, are you getting telemetry from browsers? Are you getting, you know, runtime statistics from your server farm? Like there's all these different sources. So like it's kind of by definition like heterogeneous or really mixed. So finding ways to make interoperability between those parts better, I think, is some of the cool, interesting stuff.
So if you've got a bunch of folks who like R and a bunch of folks who like Python, they build their things, and then you can spit out WebAssembly from that. You can just bolt them together because they're just running in the browser. Yeah, interesting. Yeah, you never thought about WebAssembly as a way of bringing together a lot of different technologies like that. That's yeah, that's a cool idea, actually. I need to play more with WebAssembly. I did a stream with PyScript. Put a link to PyScript in the chat. But I did a stream where I was just playing with PyScript, just kind of try it out, see what it's like, and it seemed pretty good. So yeah, to try and use that to build data pipelines into WebAssembly. Getting ideas for more streams at some point. Could be good. Brian Abbott asked the interesting question. I'm not sure how much we can comment on this. Is Microsoft actually hiring right now? I would love to work there. The software company. How much better can it be than that? And this move with OpenAI, they still 1000% still got it. That's a good question. I'm sure, as you are well aware, we are going through a series of layoffs at the moment. It's publicly announced they're laying off 10,000 people across Microsoft, but there are still open roles. know how many at the moment. In fact, if I just click find jobs with everything. Okay, there's 500 open roles. 625 in total, 500 for experienced professionals, 126 for students and graduates. So I'll drop a link in the chat. I can't comment on when that number will go back up. That used to be in the tens of thousands, and then obviously it dropped. So I can't really comment on what the future hiring may or may not be at Microsoft. But yes, there is a few jobs going. But obviously, as we're all aware, there's a lot of folks being laid off in the tech industry. So of those 625 jobs or 500 jobs for professionals, there's 10,000 people at Microsoft who might be looking for those jobs. So it's a very competitive time. No idea when things might get better. Faiz Khan says, it might be hard to follow as I use poetry. So this is for your version of the Sudoku solver using poetry. Okay, that could be interesting to see. But you know what? We're 35 minutes in. We haven't even looked at code yet. Should we see if we can do our version of it? This is what happened last time. This is where we got nowhere, which is cool. Absolutely, which is fine. We're here to answer your questions. We're here to help and support you. So, it doesn't matter. We're here to chat. That's half the fun. So we've got so the problem we're trying to solve, if you weren't here last week, is a Sudoku validator. So given a board, an initial state of Sudoku, so given a board with some of the numbers filled in, is this initial state valid? So Sudoku is a problem where you have a 9x9 board split into 9 3x3 cells, and you have to put the numbers 1 to 9 in every vertical line, horizontal line, and box. So in this box here, you have to have the numbers 1 to 9, and this line here is numbers 1 to 9, this one here is numbers 1 to 9, and so on, and so on, and so on. And the idea of a validator is it looks at the initial state of the board and tries to determine whether or not that is valid. Not whether the board is solvable, but is that initial state valid? This one here, for example, is. This one here isn't, because in this cell, we have 2 6s. You can't have that. You just have to have the numbers 1 to 9. This row has 2 6s. Again, you have to have the numbers 1 to 9. This column has 2 6s. Again, you can't do that. You have to have the numbers 1 to 9. So our job is to be, when given a board, can we validate the board? Do
you play Sudoku, Jim?
I when it was the big thing for a while, I did. I haven't. It was. I guess it's like Wordle. It's big and famous, and everyone does it, and then after a while, everyone stops doing it. So I don't do it anymore. Do you? Do you do?
Probably not as much anymore, but for a while, I was very, very into Sudoku, and yeah, I had actually at one point did like a big research, like undergrad research project on how to classify difficulty of Sudoku problems. So I like Sudoku. This is a good problem.
Awesome. So this is, Jay actually said last time that they really like Sudoku as well. So if they get distracted, they might actually start trying to solve the problem rather than actually solve the problem trying to solve in code. So I guess this is the part where we think about how we're going to implement this. And we didn't get, so last time we didn't get far. Last time we actually started looking at code. Jay started playing with data classes and just fleshing out their ideas around what kind of structure they might use for representing the data. We touched a little bit on tests, that you can have use PyTest or run tests in any Python file that starts with test. Didn't really get anywhere. So I guess this is, Sarah, this is your chance to either throw away Jay's code or improve it and give us your thoughts. Well, before we do, thing from Alistair Sanchez saying there are other good IT companies beside Microsoft, Apple, Facebook, or Google that are actually actively hiring. Yeah, there is a big layoff in tech at the moment. I mean, Amazon announced another 9,000 earlier this week or last week. Apple haven't done any layoffs. They've been quite active in reducing executive compensation and not doing layoffs. Facebook or Meta have done a lot, and they're talking about doing more, especially in the area of management. So there are big tech companies, but there's a lot of small tech companies hiring as well. There's a lot of startups and small tech companies that are trying to take advantage of this massive glut of people who are now looking for work. So yes, Microsoft is cool, but if you can't get into Microsoft, there are there are other options, and it still seems like the number of open positions in tech is much higher than the number of people needed to fill them. It's just obviously the competition is higher. So yeah, still plenty of cool companies to work for, and you never know, you might work for a small company that gets bought by Microsoft, and then you end up here anyway. You never know. Cool. So Jay Miller has made a suggestion as to what we should do with the code, which is throw it all away. So the entire effort of last week should be thrown away. What do you reckon, Sarah? How would you model this data? Because you're more of an expert than I am.
Yeah, I don't want to throw it away, but my proposal would be, yeah, I'll say kind of what I was thinking, which is I like NumPy arrays. They're kind of my go-to. Even if something doesn't fit in it, I will probably try to serialize it and or make it fit into NumPy/pandas sort of infrastructure, because those are, for me, being a scientist, kind of my daily driver sorts of, I guess, tools. So, and at least in this case, a Sudoku grid does kind of look like an array. So that would be seems to me kind of a natural thing given what tools I work on and the problem we're trying to look at here.
Cool. Okay, so what I'm going to do, I'm going to pip install NumPy then. And so when we did this last week, I was using Python 3.9, and Jay described it as doing it on hard mode. So I thought I'd actually update my Python version. So we're now using 3.11. So
Nice.
Sorry, Jay, if you had on hard mode, but I have updated since, and we have turned off GitHub Copilot because we don't want to cheat. This is not about can we use Copilot to do it. Maybe next week we'll see how quickly Copilot can solve the same problems. But we're not using.
Honestly,
Copilot.
That would be really fun.
Yeah, it'd be kind of a good way to wrap it up. Is we do it and then see what Copilot does and just compare.
Mm-hmm.
So yeah, Jay says I wanted to go that route, but not being a scientist, I don't play with NumPy all that much. And then, woo, the speed. Yes. Cool. So we have NumPy installed. I keep on calling it NumPy, but you say NumPy. Is NumPy the correct?
This is like a GIF situation, I think. Like, I have heard both from I work with some of the NumPy developers. I always say NumPy, I guess. As is obvious, but.
So I guess you think about the word dumpy. That's not the same way. It's just dumpy with an N, isn't it? Dumpy, NumPy.
Yeah, I guess.
Dumpy. I mean, we all know that GIF is GIF with a hard G because it's GIF for graphics. And I'm sure the chat will now be full of people saying, no, it's GIF, like the bathroom cleaner and the peanut butter. So Brian Abbott says you could do quick and dirty numerical array based on a 2D array. We could code that up in 20 or an OO thing that would encode the rules of each object, and maybe that sits on top of the 2D array. Yeah, I think this is going back to what one thing Jay was saying is the one advantage of putting it inside classes is if you then needed to expand on this because you want to actually build the Sudoku game, you kind of have that validation logic into the class. So when you click on the when you actually try and set a number in the cell, because the validation is built in the class automatically, that can say no, you can't do that, because it's the same validation we use for the board as the validation we do for each time you make a move as well, each time you do a number, because that's another state of the board you're checking for validation. So that was kind of Jay's thoughts there. Jay Miller says if we can get Copilot X, I mean, that could be quite cool. We can't get access to that yet. I'm sure we will one day. Then Brian Abbott's leaning into the NumPy thing with Pyathon, NumPy, cherry pie, apple pie, pumpkin pie. Pie. Oh, I really fancy some pie now. So John Liu chimes in. Actually, John was here last week and says, I believe it was asked last week, but during the post-loop debrief, something like the candidate did it in NumPy or the candidate couldn't do it in NumPy ever come up as a positive or a negative? So that's a kind of a good question. If you're solving this in an interview, if you do it in NumPy, is that a bad thing? Or if you don't do it in NumPy, is that a bad thing? I mean, I would guess that if it's a data science role, if you use NumPy, that would be a good thing because that's the kind of thing you might be using. I mean, if NumPy had a Sudoku solver function on it, that might be a bad thing. Or then again, it might be a good thing because it's showing you that you know the libraries. So, yeah, well, what are your thoughts, Sarah? If you're interviewing somebody and they use NumPy for this problem, would that be a good thing or a bad thing?
To me, that would be a good thing. Like, I mean, for the record, I hate these technical interviews. When you suggested this, I was like, all kinds of like flashbacks to awful experiences. Like, oh, I don't know. But
I guess earlier on the Rust stream said when she approaches, the way she approaches these interview problems is with anxiety.
Yeah.
I think that applies to all of us.
Like, it doesn't in some sense matter how well I know things under that sort of pressure. Like, sometimes I'm just staring at the editor and it's like, it's as blank as my mind is. But yeah, if I'm doing an interview or something like that, and I am forced to do something like this where it's a technical interview, normally I like to just talk to people about projects that they've worked on and just have them show me things that they've written when they have, not been under those sorts of stressful situations. But yeah, in general, I think it's good. Okay, if there's a one-liner that just solves the problem, I don't know, I'd still probably accept it. And like, as I think is fairly common with these, like, if either you don't get it or you get it like kind of too quickly, the interviewer often talk to you and like ask about what other things could you have tried. So, kind of like you were mentioning before, and folks in chat, like the object-oriented encode the rules in the class structure and stuff, versus me, who's probably going to approach this in a very like brute force using iterators sort of way. The interviewer could probably try and ask you about the other approach that you didn't take, if there's extra time. But
because really the important thing for me with these kind of things is the conversation, isn't it? It's the idea that if you're solving this problems with people around you, or just whether it's one interviewer or whatever, the conversation you have, the talking about it, I'm going to make this assumption about the test case, therefore this is why I'm going to write this code this way, and just you document through comments your thought process. You document out loud through conversation your thought process. That is to me is the most value, because if you can't solve the problem but you can explain in so much detail why you think you're doing a particular approach, how the language works, that is better than just, oh yes, you made it work. Because one of the biggest downsides of these tests is a lot of them is down to memory. Can you remember which data structure and algorithm to use for this particular LeetCode problem, which is not the sign of a good programmer. But if you've got the ability to talk about it when you approach a problem, that is the sign of a good programmer. The number one most important skill you need to have in the tech industry is communication. That beats what expertise in every programming language. The ability to communicate is so important. And so, yeah, if you're approaching these problems, you've got to talk out loud to the people in the room. You've got to then actually have the conversations around why you're thinking these things. And Jay Miller actually makes the point. I love that Sarah and I are colleagues with much different backgrounds. Me, I'm more object and web platform design, and Sarah shows me all the ML and fun data stuff. Yeah, people approach problems different ways. That's why I was really excited when I approached Jay and Sarah, and they said, Jay said, I can do one these days. Sarah said, I can do another one these days. It's kind of nice because you get two different people's opinions on things, which is kind of really cool, because there is no one right or wrong answer necessarily. A lot of it is there are different ways to approach these problems. Alistair Sanchez says, I wouldn't judge the candidate on what library they use. Yep, that's the right answer. If an interviewer does judge you on that, maybe that's a red flag for the company, somebody you don't want to work for. John Lewis says, I kind of equate it to the idea of using collections.counter in Python to offload some of the manual processing. Yes, if there's a library you can do that does something, why wouldn't you use it? Fashat says, hello all. I never like writing new code in interview. I think it's a bad way to determine a person's skill set. The real question, can they think out loud how to solve the problem? Yes. Yeah. I mean, I have strong opinions on this, so I guess you have strong opinions, and they sound like they're pointing in the same direction as my strong opinions. So yeah, if you are an interviewer, top tip: don't do these problems, especially not in a go off and do these problems by yourself thing. There's the better way to get an idea on how someone codes is to get them to talk through how their solutions, get them to think out loud and solve problems. That's communication is the thing you need. So important. Jay says, I think my solutions in the process also show mindset. I've been looking at hardening my other projects, so I tackle this in a way where all the hardening is up front. Yeah, so Jay's idea of we have this data class with all this validation in it up front. Yeah, so kind of do that hardening. So Alistair says, first thing to ask about this validator thingy. What do you mean by validate? Yeah, so by validate, it is, is this initial state valid in that every, there's no numbers repeated in each 3x3 grid or row or column. So this one here, we've got the number 6 twice in this column, which is an invalid board, twice in this 3x3 square, which is an invalid board, and twice in this row, which is an invalid board. So that's why that's not valid. Right. So Sarah, I'm hearing typing. Things are happening.
Yes. Oh, does it not show? I am here. Let's see. It looks like I have to save it.
I do not have autosave turned on. Top tip, folks, if you don't know this, and the file menu of Visual Studio Code is an autosave function. You turn that on, every time you type, it saves.
Sweet. Yeah, I didn't want to blow away everything Jay had. Also, it is interesting, some of my keyboard things are not being respected here, so like keyboard shortcuts, so I may have to ask you for help, like typing things.
I can type, I can do that.
No, for a second I thought my shift stuff wasn't working. So I kind of just wrote here some rough pseudocode. This is like, when I approach these sort of problems, I always want to try and talk through, like whether it's in my head or on the paper or with the interviewer, kind of what are the steps to what we need to do. You just went through what it was to do the validation, to validate a puzzle. Mm-hmm. And a couple interesting caveats to note here, I think, is the puzzle doesn't have to be filled in all the way, right?
Mm-hmm.
That's and so let's make
analyzing the initial state where it's not going to be filled in.
Right. Yeah. So if we're representing this as arrays or representing these as NumPy matrices, coffee more. I'm going to say, let's use, and I'm just going to write this down here. Let's use 0 as a placeholder for an empty, because that's not a valid number. And that means you can do things with sparse arrays in NumPy. That's totally fine. Normally you would do that where like you have giant matrices and you're only really keeping sparse array manipulation is efficient when you have giant things that are mostly empty and just a few things that aren't. Our Sudoku puzzles aren't big enough for that sort of scaling performance to matter. So I'm just going to make them fully fleshed out arrays. And I will call them, I'm just going to write assumptions here.
Okay, and what you're doing here is, this is really good. So top tip for folks in interviews, by having comments, you're actually documenting these things as you're talking about them. You don't have to remember it, do you? Yeah, it's written down so you can forget about it. What are my assumptions? They're written down here. When you're actually writing code, you can check back against those assumptions. If the interviewer says, what are your assumptions? Like, well, let me scroll to the top of the file. Here are my assumptions. So it's kind of good for doing that.
I've also sometimes run into problems and the interviewer just is like, remember what you assumed. That is the answer. So it's good. Call forward sometimes too. I think the other thing that I was thinking about with this is a valid. When I was first thinking about this, I think I was making it way too complicated, because that's something I absolutely always do with these interview problems, is I make it way harder than it needs to be. I think of all these features to add. This is not something that solves the Sudoku puzzle, and this isn't something that checks if there is a valid solution. Mm-hmm. So it is the case that you can have a valid board, like at that time it is valid, but there isn't a valid solution from there. Mm-hmm. So thankfully, in my head, initially, validator was trying to validate there was a valid solution. And so I was like, if I understand correctly, that's not part of what this problem is, right?
Yeah. So I guess this leads to another top tip of read the problem. Yeah, we should learn this doing exams in school, but read the question. So we actually look at the question. This puzzle doesn't need to be solved or be solvable. It just needs to be valid. That is documented in the question. So when you think about assumptions to these problems, it's what's actually written down. What have I been told by the person saying this problem? And part of actually having this in there is, can you read requirements? If you're given a piece of work to do and you've given documented requirements, are you actually going to read those requirements? Because if you don't, then that could be a negative for you in terms of applying for the job. But also the requirements could be wrong. There could be contradictory requirements. And it's great to better bring those up and say, look, you said this in the requirement and you said this, I cannot do both. Kind of just gives you that kind of base set to actually start asking the person who's doing the interview questions around this. Thies Khan says, I'm updating my Sudoku solution to communicate with comments. Great thing to do. You can never have enough comments. I know some people say, oh, you don't need code comments. Your code should be self-documenting. Utter rubbish. Code can tell you what it does. It cannot tell you why it does it. It's like the assumptions we've got up here. If you don't have those written down, you're not going to know why the code does what it does. Why is 0 an empty cell? We don't know because that assumption hasn't been documented. So comment all the things. Ashok Tax says there are two ways: functional programming, as Sarah does, versus OOP, as Jay did. Yep, there's multiple ways to solve these problems. Functional programming versus object-oriented. Again, that depends on what language you're using. You know, if you start doing object-oriented programming in F#, then you can do it, but people might give you questions. But depending on the tool, Python can do both. So it's what you think is the most appropriate way. Fashat says, you guys looking for chat input on this validation? Yep. Of course, definitely. This is what we want you to tell us if we're doing things wrong, if you've got thoughts. Jay Miller says, hey, our mate thinks it's extremely complicated. Why not? Nothing wrong with that. Carderum says, read the problem once, then a couple hundred more times. Yes, read the problem, reread the problem, and then document things like Sarah's been doing quickly here. Document some things based off those requirements. So you've got them there so you can see them. You don't have to keep going back to the problem. Fashat says 30-second comment will save about 2 hours of research what the code is doing. Sometimes more than 2 hours. Yeah, you can spend days trying to work out what the heck a piece of code is doing that could be put in a comment. But top tip, if you're ever looking at code and it takes you ages to work out what it's doing, write the comment. Raise a pull request with the comment, put the comment in there so that other people don't hit the same problem. Alistair Sanchez says, since we're not required to check the solvability, it becomes super easy. I wouldn't say super easy, but it is easier. And Ritvi says, hey, Jim. Hey, Ritvi. Welcome. Glad to have you here. Awesome. Ritvi is a former Microsoft Learn student ambassador. Might even still be a student ambassador, actually, based out in India. Really good to have you here. Ritvi does awesome stuff with IoT devices and glass. Cool. Highly recommend. Ritvi, if you want to drop any YouTube videos in the chat, I'd love to share with everyone because I know you've done a cool reactor session where you've been doing some very cool stuff with copper tape for wiring, glass, and IoT devices. Ritvi's awesome. Sorry, so you've been typing, and I haven't been involved. I've been reading questions.
No, it's okay. I know we're short on time, so I'm trying to just at least get some infrastructure down here.
Yeah, I've got a feeling we'll get back as far as we did with Jay because we've only got like a minute left. We'll have to come back to this next week because we've been chatting to everyone because everyone's awesome, and that's cool. We're happy with that. Eunice says, personally, when I'm presented with any coding problem, I usually underline or take note of key points and words. It makes it easy to break down the problem into small parts. Yeah, that's kind of a good idea. When you've got this, can we highlight this part? This is important. 9x9 grid, 9 3x3 grids. Yeah, good thing to do. Actually note down those important parts. Brian Abbott says, and I'm paraphrasing, F# is an attractive beast. That John Lewis says is not as attractive as COBOL. If you ever make it to Microsoft React and Redmond, we have an original Microsoft COBOL box with the floppy disk, 3.5-inch floppy disk of COBOL. So, okay, so maybe, John Lou, we could get you on a stream and you could solve these problems in COBOL. Oh, Ritvi has posted links. Oh, sorry, Ritvi's posted some links, but they've been starred because of the various blocking things that block people posting links. Moderation. That was the word. I forgot the word moderation. Okay, so Ritvi, what's your social media handle so that folks can follow you and check out your stuff? That might be easier. Sorry, link's not been posted. But yeah, follow Ritvi on social media and then check out all the cool stuff she's doing. Brian says you guys are awesome. There's a lot of fun and inspiring. I'm going to do a Sudoku solver now. And then John Lou said I'm going to eBay for punch cards. So right, so check out Frenzy Ritz 13. Ritvi does some incredible stuff. She's done a Microsoft Reactor video with us as well. But yeah, follow Ritvi for some incredible stuff with glass, IoT devices, and other cool bits and pieces. Absolutely inspiring person. Now Sarah's obviously started padding this out, but we do have to stop here. So Sarah started padding out. We've got a function to look with the subpart is valid, and we've got a function to check a grid. And this is the part where we have to stop because someone else might be jumping on the Twitch stream and we don't want to go past everyone. So we'll check in the code that we've got so far into our GitHub repo. I'll just drop another link to that in the chat to make sure everyone's got that. But otherwise, join us next week. Jay will probably be back next week because this is going to be interesting to see what Jay does. Unless Sarah, you've got time to join next week. So see who we have next week, and maybe we'll get some kind of bun fight going between the two of them as to work out what is the best way to solve this problem. And obviously, the best way to solve this problem is to have lots of conversation and not enough code, which is cool. So thank you everyone for joining. Really appreciate you taking the time to join us. Thank you, Sarah, for hanging out and sharing your love of Python-powered lasers. This has been really cool. Thank you everyone who jumped in the chat to share all their things. It's been great hanging out with everyone. But with that, enjoy the rest of your day wherever you're in the world, and we'll see you next week.
See everybody.
Bye.